Hello, hello, and thanks for joining me once again in the wacky world of Synapse Analytics. Now, we have done a whole load of different videos in the Synapse world. We've done lots of looking at Spark, including the brand new preview of Spark 3.2. We've had a look at Synapse Serverless and how we actually query it and do that whole on-demand querying. We've done lots of videos in the past about dedicated SQL pools and what we can do with the big, giant MPP, massively parallel processing scale. What I haven't really done, because I'm a data engineer, is dig too heavily into the data sciencey side of things. So today we are going to have a look at some of the features we can do using AutoML inside the Synapse Analytics workspace and how we do that, how the predict function works, how we plug all those things together in the Synapse environment. Now, it's not me. I'm not a data scientist. I'm a data engineer. So we've got, as always, our guest data scientist, Gavi, who I'll introduce in just a moment, who's going to help us navigate the wacky world of Synapse data science. As always, do not forget to like and subscribe, and let us know down in the comments if you're already using Synapse Data Science, if you're building ML, if you're using Azure ML and plugging it into Synapse. It'd be good to hear how you are currently working in that ecosystem. Right, let's get Gavi on. Hello, Gavi. Welcome back to the show.
Hi, Simon. How are you doing?
I'm doing good. I'm eager to learn. I'm eager to soak in the data sciencey knowledge. How are you?
Good stuff. I've seen a lot of your videos in the past anyway, and they've all been brilliant. But what I'm here to talk about is the data science and machine learning.
Which you don't want me talking about. That's not going to go well.
I'm sure you do a good job of it, Simon. You do perfect.
Right. Do you want to say, in your words, what we're going to go through? What are we talking about today?
Right, so we're going to look at Synapse. We're going to look at the functionality of Synapse out of the box, right? You've got Spark. You can spin up the cluster. You can train a machine learning model. You can score it or predict it. Or use it to predict it, sorry. But what we're going to really do is go down the no-code road or low-code road, right? So what we're going to do is create link services to Azure ML, train the model up using automated machine learning, bring it back into our dedicated SQL Pool database, and use the data that we've uploaded and score it. We're using T-SQL.
Right, that's an ambitious load of things to get through.
It is, but we can do it. We can do it. We've got a blog. We've got a step-by-step blog written up. So in case I've missed anything, it'll all be covered in the blog as well.
Sounds like a plan. All right, I'm going to switch over into your demo screen so we can see what you're doing, and then you can take us through this whole pile of work.
Cool. So there's really 3 steps to this, right? And it's common with all data science machine learning projects. 3 steps being, first thing is prepare your data, prepare your workspace. Second step being train a suitable machine learning model. And like I've said, we're going to be using the AutoML functionality within the Azure Machine Learning Studio. And the third step is then to bring in back that model, deploy it to the SQL Pool database, and we're going to use the model to predict and score against our unseen test data set. So those are the 3 things. A few things, a few niggles. To use Azure ML, we can't spin up the latest and greatest Spark cluster. We've got to use 2.4, otherwise we'll run into lots of errors, Simon. Yeah.
I mean, so from a data engineering point of view, you miss a load of features for that. But if you're not using a lot of the adaptive query processing and all that kind of new fancy stuff, it makes a lot of sense. It's still the same Spark engine. All right.
Okay, and so that's one thing to remember, and I'll mention it again. The other thing to remember is because we're not moving our data out of our warehouse into Azure ML, what we need to do when we train the model in Azure ML is to make sure it's got Onyx compatibility. And what that means is we can then port it across back into Synapse and use it to score the unseen data. So those are the 2 key things we need to remember. So if you haven't seen Synapse before, this is what it looks like, the landing page. It's nice and shiny. You've got your data, your develop tab, your integrate tab. And what we're going to do is, let's look at, this is going to be a bit of a cooking show, Simon. So I've run a lot of the scripts before, and I'm going to say, ta-da, here's how you do it. But hopefully...
We're going Blue Peter. We've got, here's one you made earlier, which is only going to make sense to British people.
Exactly. So the thing to do first, right, is to make sure that we've got our data into our lake. So I've uploaded that. The data that I'm working with today is a churn data set. And I think in the machine learning world, that's one of the top use cases implemented and deployed in businesses. Most businesses look at churn prediction. So what I would like to do is upload that data and see how Synapse deals with it.
So for people who aren't that familiar with machine learning, churn is where you've got either employees who might leave or subscribers who might not renew, any customer who might not buy again and kind of keep coming back, and it's the who's in danger of leaving, and you should be treating a little bit more TLC to get them to stay, right?
Yeah, exactly. And if you've got that information and if you're able to predict, if you know that certain customers are going to churn, right, what that really gives businesses is actionable set of things that they can do. Perhaps if they can anticipate people leaving a service or a business, they can say, hey, don't leave. Why don't you have a free trial on us? And you can do different things like that to make sure that you retain customers. And there's loads of figures out there, right, saying how by trying to retain customers increases profit from, I think, 10% or 90%. There's some figures out there that's been quoted on the blog as well, but it's immense advantageous just to look at churn prediction in whatever business you might have. Cool. So what I've done here, right? So if you go onto your data tab, you've got your workspace and your linked. In your linked option, I've got my your ADLS storage, Gen 2, where I have already uploaded my data set. So if I go into my data set, I've got loads and loads of data set that I've played with previously. But what we're looking at, like I've mentioned, is the churn data set. So I've uploaded a training data set. It's a big machine learning data set. And I've got a testing data set as well. Okay, so what I really need to do is make sure that if you're working with CSV files, then you need to make sure that you upload your data set using the Spark cluster onto your table.
Okay, so you've done a bit of work, you've prepped some data, and you've already done your sampling ratio to split it out into your two different sets. You've landed it in the lake, ready to go.
Yeah. Okay, so if you're using the SQL warehouse, you probably have data coming into the warehouse, so you don't have to worry about it. But if you want to train your data, then you need that separation to make sure that you use that data set, throw it into a model. The model learns different patterns and says, hey, based on your patterns, based on your data, this is the best model. So I've already done that. So if I go on to my workspace, I've written the churn, the big ML, onto a table called telecom churn. So if you do this, you can see all the different columns that's been written out already. That's a good way just to validate your data set, right? Now, what we intend to do, so we've prepped our data, we've prepped our training data. We haven't prepped our testing data. Now, our testing data, because in anticipation of using T-SQL and the predict statement, we need to upload our testing data to the SQL Pool database. Sorry, the SQL database using SQL Pool. Right, to do that, I'm not a SQL person. I'm not great. I can do basic SQL, but what I've really leveraged here is to use the GUI stuff, the wizard that Synapse has available for all of us to use. And you can use couple of wizards to just get you used to what kind of parameters to fill in. And then you've got the flexibility to add more code if you wanted to. So all I did was I right-clicked on my testing data, go on to new SQL script, right? And I used the bulk load option. So, which is easy, really easy.
Bulk load is good because it uses the copy into statement, which is... Exactly. It needs the fewest permissions to be able to do data loads, and it uses an engine similar to Polybase. Good way of getting data into dedicated SQL pools. It's just wizards, Gavi wizards.
I like it. So, just
we're talking low code. Wizards
learning.
Is fine. It's an easy way to do it without bothering writing a load of script. It makes a lot of sense.
But what I've done here really is also I've used it to check my data, to check all the steps are correct so that I don't want to waste time learning SQL, learning how to do things right. I just want to make sure I'm accelerating the machine learning process. So that's what I've done. I've used the bulk load option and I've got my testing data set into here. So like I said, played with loads and loads of different stuff that I've written it to. It's called one of these. It's a test orange churn data set. So just to make sure I've got the right columns and they all look right. They all have these features that I recognize from the data set. Okay, so step 1, done. Deploy and set up the Synapse space. One thing we're forgetting is, out of the box, when we deploy Synapse, it doesn't have your links to Azure ML or cognitive services if you're wanting to use an out-of-the-box AI model. So what you really need to do is make sure you have your service principals set up and you're linking both of those applications together so that Synapse then is able to talk to your ML and saying, hey, I've got a model to be trained. I'm going to throw it across the fence. Let me know when you're done with things. So I've also already done that. And the way to make sure you link everything up is to go on to manage. In your link services, I've got a couple of link services that I've linked up. So make sure that you link it up properly. The details are in the blog, and there's loads of other tutorials out there to guide people through this.
Yeah, it makes sense.
Cool. So step 1, done. So what we're going to do now is train a machine learning model using Azure ML. The way to do this, let's head back to our data tab. In our lake database, all I do is you've got 3 dots, 3 little dots, blue dots. Right click on it, get a couple of options right. Machine learning. And what we're doing, Simon? We're training a new model. As easy as that. Yeah, anyone can do this, right? So we're dealing with a churn problem here. So again, you go through a wizard, you've got train new model wizard. What do you want to do? Do you want to do a regression problem? Do you want to do a forecasting problem or a classification problem? So we're going to choose classification. And it's as easy as click, click, click. So you click, continue. You link, so if you've linked your workspace, you'll have a choice down here. I've done it in both ways, a service principal and a link service. So I can click any one of those because I know it works. The experiment name and burst model name has been already populated by Synapse. If you want to change it, you can change it. I've left it as is. The target column is where we're trying to predict, which column we're trying to predict. So in this case, in this data set, or this problem rather, we are looking at predicting churn. So again, right, you scroll down, you pick on it, you pick the right column that you want to predict. As I said earlier, the AutoML functionality only works with Spark 2.4. So I've previously spun up a Spark 3.0, hit loads of errors, and I've learned that, you need to, it's also mentioned in the Microsoft pages as well, only works with 2.4.
If you read the documentation, you wouldn't hit the error.
Exactly.
Okay.
Yeah. Don't be hasty like me. Don't jump into the deep end.
Okay, cool.
You continue, you choose the right metrics that you want to validate your data. You can change your maximum training job time. You can drop it down to 1 hour. What's important here is if you're training your machine learning model in Azure ML and you're intending to bring it back into Synapse, you've got to make sure that the Onyx model compatibility is set to enable.
Yeah, because the Onyx is a common communication protocol. It's a wrapper around models so that you can have it in a standard, so you can do it in different places and actually make it more transferable across a lot of different.
Yeah, the way I think about it is getting somebody else to train a model, and it's packaged into a suitcase, and you can bring it back. So portability is great.
Smuggling models around in suitcases. Okay.
Right from
if people at home are wondering about the training time, so that's 3 hours. That's a lot of time. That's because it's doing AutoML, so it's trying out a huge raft of different approaches, and it's how long it wants to spend trying out so many different ones to try and find an accurate model. Is that right?
Yes. I mean, the minimum you can bring it down to is 0.25, a quarter of an hour. Maximum is 3. The longer you leave it, obviously it gives Azure ML the ability to get you the best possible model. But if you push for time, you can put it down to 0.25 for half an hour or an hour, whatever you want, really. Yeah, and from here you've got 2 options. You can just click Create Run, or you can open it up in a notebook and have a look at the code, what it's really doing, which I tend to kind of have a peep saying, oh, I can do this, I can add to this. So if you like code, if you're comfortable with notebooks, it gives you that flexibility as well. But for the demo today, we're going to click on Create Run and leave it in the background. So what it's doing now is it's summiting an AutoML run.
We're not going to wait an hour. It's going to be a long video.
No, we're not going to wait for an hour because, like I said, this is a cooking show. I've prepped everything up, and I'm going to say, here's what I've done previously. Right. So
Right, so you're going to open the oven, and we're going to get out some freshly baked models, and you can show us what you've got.
Yeah, absolutely. So that's done, right? So I've trained the model now, or Azure ML is doing all the background work for me. And if you wanted to have a look at what it's doing, you can always snip across, and you can have a look at what's happening with the AutoML runs. So it's still talking, so you won't really see it running. But here's what we did before. We ran it this morning. We submitted an Azure AutoML run, and it will appear here as it's running. So it's talking to each other. So this is kind of a good way to check what it's doing. And you can have a play around what kind of models that you've registered before, the experiments, the data set, lots and lots of different things to play with here. The other option is if you're working in an organization where you've got data engineers that are using Synapse and you've got data scientists that predominantly build your models using notebooks in Azure ML, they could be building out your best machine learning model here. But it still gives the data professionals the ability to then say, hang on a minute, I'd like that model. Can I port it across and use it to score the data that's coming into the warehouse?
Makes sense.
Cool. So let's go back to this. So if we assume, if you take my word for it and it all works, right, and Azure ML gives you the best model, it will also register the model into the model registry as an Onyx compatible model. What we then do is we scroll down to our SQL database.
But there's a quick one there. Is it so after it's done all its AutoML, it's automatically going to pick which is the best performing one, and that's the one it registers. So it's not you pick from a list of its 10 top ones. It just takes the first one and registers that for you.
That's right. It picks based on the metric that you choose to validate your data sets with. It will say based on say an accuracy metrics, this is your best model.
Yeah. Oh, all right.
Right. So it does all the hard work behind the doors for you. So we can be going now making a cup of coffee and getting a slice of cake. So
nice and easy.
So yeah, so then what we do is, right, so that's step 2 done. We've trained a model. What we need to do now is come back and score the data set. Okay, so the way we do this is we come back to our database. Again, you see these 3 little blue dots. You get several options. You right click.
Ellipses. Or the 3 dots, it's fine.
3 dots. And what we're trying to do here is we're going to predict with the model. So you click on your machine learning option, predict with the model. And again, you get this result, right? They'll say, I've got loads and loads of models based on what you've trained in Azure ML. And what model would you like to use? What model would you like to score your data set with? So it's a matter of looking down saying, I know, I've trained it last night. I would like to go with that model, please. Carry on. And you get to the next screen where you can just make sure that all your source columns are matched to your model input. So it's quite clever to do that. And it's a matter of just making sure your output mapping is correct. We don't want the probability, so I'm going to delete that particular output mapping. I just want an output label and give me whether a customer is going to churn, whether it's going to be true or false. And if I click on continue, what it's doing now, it's getting that particular model in Onyx compatibility and deploying it in the SQL database. Okay, so it's converting it to hexadecimal and making sure that it can all read it. It can read the machine learning model that you've trained.
Yeah, makes sense.
One step that we need to also make sure we're filling out is store your procedure name, right? So we can then rerun this again many, many times if you want to. So it's a matter of just filling it in. Can't spell.
I'll let you off.
What would you call it, Simon?
Okay, so each time it's going to drop and recreate that table with all the scoring done to it, yeah?
Yeah, exactly, right. I can deploy the model and open the script. So what it does is it's uploading the model as it's notifying me, and it'll deploy the model into the database. Okay, so you get notification soon enough to let you know that that's done. But I've already done this, and we've got a script already open. So let's give it a couple more seconds. Usually it's very quick.
Work will work.
It will. Look, it's deploying the model. It's because I'm also asking it to, hey, go and train a model. Hey, deploy a model for me. And look, it's done it, right? So it generates a SQL script. And it says, based on what I want to do, I want to use the data in the SQL database, and I'm going to use the tsql predict command to make a prediction. And all we do, right, is run this. And if I run this now, what I'm going to expect is to see the scoring done to the unseen data set. So let's go for it. Click run. It's starting, it's retrieving. It usually 10 seconds tops, tends to give you back the results with the, oh, there we go, with the output label. So it's work. So there you go. So you've got the unseen data set, the output label where the customer is going to churn, it'll be false. A true, sorry. If they're not going to churn, then it'll be a false. So you've got your true and false label all done for you without having to take data out from your database. And yeah, this is how we're going to leverage, or how we've leveraged machine learning, automated machine learning from Azure ML.
Very cool. I mean, especially that kind of, that little step of, so normally kind of when you're in SQL Server using the predict function, it's a real pain to take the model and get it jammed into the SQL Server so you can actually access it via predict. And then it's nice and easy for SQL developers to use the predict function. But that whole wrapping the model, getting it in the Onyx format, somehow squeezing it into a SQL Server, it's historically been a bit of a pain. So
yes.
The fact that it's just wraps it up, registers it with a repository, and then just registers it inside your SQL is pretty cool.
I think it is. And the functionality keeps increasing. Microsoft keeps expanding functionality, right? So I'm really looking forward to seeing what other capabilities they're going to come up with.
So could you break this apart a little? So the model that is produced via AutoML, could you take that and use that in Spark or use it elsewhere and not just do it in Predict?
Yeah, you could. Yeah, because it's registered in model registry in Azure ML. It's just a matter of calling the best model, the best run, and saying, hey, I want to be doing this in Spark. You can, yeah, the options are endless.
And the other way around. So if you build a model yourself and you put it into the model registry, you can use that to squeeze that into a dedicated SQL pool and you predict that way.
Absolutely. Yeah, exactly.
That's pretty cool. So you've got like a nice big end-to-end low code-ish. It's producing some code for you, but you've not had to actually write any code yourself. And it's going all the way through that process of, I've got a problem, just tell me how to predict it, and then just make it accessible to my SQL developers directly.
Exactly. So I think it's pretty cool. Yeah, I think it's really cool. And really quick. Within 10 minutes, we've managed to say, hey, go and train a model. However long it takes, in a half an hour, 1 hour, come back and say, hey, I've got this data set here. Can you please score it for me using tsql predict?
So the horrible question. So we saw in a previous video, we had Databricks AutoML.
Yeah.
So between Synapse AutoML, Databricks AutoML, we talk about Databricks being glass box. So
yes.
What does that actually mean in terms of the differences between the two?
So what that means is you've got glass box means it's transparent, right? So you've got the code at the end of the AutoML saying, hey, this is with Databricks, this is the best model that I've trained, and here's the code with it. But you do get the same thing with Microsoft's Azure AutoML as well. Yeah, you do. So I think they have their benefits and they're different in terms of, if you're working in Synapse, for example, and you say, hey, I want to use Azure ML, that's great. Databricks has got its functionality as well. It's got its pros and benefits, so it's just different to what you're doing. You've got options, Simon, options.
Very diplomatic. But yeah, no, it's great that we have wherever you happen to be doing that, whether you are on the more Sparky Databricks side, whether you are on the more integrated SQL-y Synapse side, you've got similar tools to enable you to really, really get, like, kickstart the data science process, just get there a little bit quicker, and then start doing the deeper stuff.
That's it. Yeah.
Awesome. Very, very cool. Alrighty. So let's wrap up quickly. I'm going to switch back to the other screen. There we go. Right, so thank you for taking us through that. What's next? What are we going to look at next in the world of Synapse and data science stuff?
I mean, there's loads, right? So with the Synapse, there's also functionality of using cognitive services, and that's your out-the-block box models that you could use for sentiment analysis, for anomaly detection, and I've read they're adding and expanding more functionality to that as well. So we can look at cognitive services, and there's lots of other stuff that we can be talking about. But what I like to do is show a bit of cognitive services next. So I think that's immensely powerful as well to do sentiment analysis. If you've got a bunch of emails and you've got it in your data warehouse to do sentiment analysis, it's also clickety click click. You get your results.
Clickety click click. There, your new catchphrase. All right, very cool. So yeah, I'm going to drag you back to talk more about that kind of stuff in future videos. And there's more Databricks videos to come, and there's more general data science stuff to come. And yeah,
Absolutely.
What's the most important thing for people watching?
To like and subscribe, Simon.
Don't forget to like and subscribe. And as always, let us know down in the comments if you're using AutoML inside Synapse, if you've managed to actually sort of, get a real business case out. If it's changed how you're currently working, then it'd be great to hear it. If you're currently using Onyx, and you're happy to see Onyx kind of spreading a little bit more as a general standard for building transferable machine learning models. It is all cool stuff. And we'll be back, I don't know, some point soon with more videos. And we'll see you then. Cheers.